Hi, I'm Mitch, and today I'm going to be walking you through a tutorial on how to use the CAM workbench from part design all the way up through actually cutting the part out of some particle board. I think it matters a lot what your tool is since you're going to be making a part in the real world here, and so I will tell you that mine is a Maslow CNC router, and I'll leave the link to the web page for Maslow in the video description. And the thing to know about this is that it can only control X, Y, and Z positions. It can't control anything about the spindle speed or tool selection. It's just X, Y, and Z positions. And so that should make this a very simple CAM tutorial. I'm going to try to make the simplest CAM part I possibly can using the fewest tools in the CAM tool bench that I possibly can, so that you can go from part design to actually producing a part as quickly as possible. And then you can come back having that confidence and do something a little bit more complicated. So to start, we are going to we're here in FreeCAD 1.0, and we're going to create a parametric part in the part design workbench. So that opened up my part design workbench, and then we're going to open up Sketcher. And in Sketcher, if you want to make things easy on yourself, choose the top of the XY plane for your sketch. CAM automatically assumes that the tool is coming from the Z plane. You can change that, but it adds one more step. So sketch and pad your part just like you normally would, and I might fast forward this because it's not the point of the video. Okay, so I've just made a 200 millimeter by 200 millimeter square that is 6.25 millimeters thick, and that should be a 1/4 inch thick because I've got a 1/4 inch piece of particle board I'm going to cut this out of. So I'm going to save this as a FreeCAD standard part. And now I can come up here and come down to the CAM workbench. So we've got a few toolbars here. You can see that here in the project setup toolbar, this includes the job tool, the post-process tool, and a checking tool. Everything else is grayed out. And so the first thing we need to do is create a job. So we create a new CAM job by clicking on the job toolbar, and since the only body available is the body I just made, that's the solid that's automatically selected. I have no template, and my body is selected. So I press OK. This brings up the task pane for the job. This starts on the Setup tab, and this and the Tools tabs are the only thing I'm going to change here. So you can browse the rest of these tabs on your own, but for now these are the only two that we need. In Setup, we can define our stock. The default is to extend the model's bounding box by 1 millimeter in every direction. So if I extend the X and Y 50 millimeters in every direction, you can see that it draws where it thinks the rest of the stock material is. If you're going to use this to cut out a 2D piece, you should also set the Z extensions to 0. And these numbers are how far the stock extends beyond the defined body, not absolute dimensions. However, defining how big your stock is doesn't really matter for this example, so I actually prefer to just use the use existing solid option. We don't need to mess with any of these other options, so let's leave them and move on to the Tools tab. The default tool is fine. this is the cutting tool you're going to use. In my case, it's a 1/4-inch router bit. The diameter of that bit will cause the geometry of my actual piece to be about 1/8 inch different from the geometry of the body I drew. We can account for that, but I'm just trying to prove I can turn a drawing of a square into a real particle board square, so we'll skip it for now. I don't need to change the tool name or number, but this H stands for horizontal feed rate, and it's in millimeters per minute. If I leave it at 0, the thing won't move. So here's where you kind of have to know your tool, and it's going to be a trial and error at first. Too slow will just cause your cut to take a long time. Too fast will break the bit or the mill. So start slow and cut shallow. I have a DeWalt router and I'm cutting particle board, so I just thought to myself, how fast would I go if I was making the cut by hand? 100 millimeters per minute is 4 inches per minute, which is slower than I would go by hand. The V is vertical feed rate in millimeters per minute. I'm going to turn that to 25 millimeters. 25 millimeters per minute. The spindle is the spindle speed, and I don't have control over that because I just turned my DeWalt router on. So I don't need to change this. So now we're done with the job edit, and I'll press OK. Now that the job is made, my other tools become available. The only two I'm going to use are the Profile tool and the Post-Process tool. We use the Profile tool to define the toolpath, so let's click on that. Now we've got 4 menus: Operation, Heights, Depths, and Base Geometry. Nothing in Operation is relevant to my router, so I'll start at Base Geometry. This is what the path is going to follow. I'll click on the top face and press Add. Done. Now I'll move on to Depths. The defaults here assume the Z-axis home is the bottom of the stock. But I've set my CNC as such that it's the top of the stock. So my stock is a 1/4 inch, my final depth has to be negative 6.25 millimeters. You should be able to double click and get a cursor. But if you can't, it's because these are made of functions. So I can click on this function button and I'll just delete this and say negative 6.25 millimeters. And OK. My start depth, I want to be a little bit above the surface of the piece, which is at 0 millimeters. So I'll maybe make that 2 millimeters. OK. A 5 millimeter step down should mean that I cover the 8.25 millimeters between vertical distance between my start and my final depth in 2 passes around this thing. And you can do a little math there. If I'm moving 100 millimeters per minute, it's going to take 2, 4, 6, 8 minutes to do one pass, and so 16 minutes to do the other. So I'm approximating that this is going to take about 16 minutes to complete this square. Next, I'll choose my heights. Again, the defaults are formulas. So I'll click. So I can't get my cursor. I'll click on the function button and make both of these 5 millimeters. And we hit OK. Now I'm ready to save my G-code. I just click the Post-Process button, and it automatically writes and we can see that this is actually the G-code. And so if I press OK, it automatically writes a .nc file with the same name and folder as the FreeCAD standard file. So let's go check that out. So here's my part file, and then here's the NC type file that the CAM software wrote. Okay, so now I can load that .nc file into my router control. This is a Maslow CNC, and so this is a Fluid NC. That's a Maslow specific program. So yours isn't going to look like this. I don't know what your CNC program is going to use. And I've got my Maslow all set up on the frame here, and it's ready to go. So I just need to upload G-code. Come and find my CAM tutorial square.nc. Find it now in my drop down menu. There it is. Okay, and it's putting my home somewhere far away. I want my home to be right in the center here, so I should be able to say define home XYZ, and now you can see the toolpath. So it's going to come up from the center of the square, so where the CNC is located now is at the center of my square, and it's going to raise up, come out to a corner, and then do 1-2 passes, and you can see those 1-2 passes there. So all I need to do now is turn on my router manually and start this. So I'm going to go turn on my router, and you should hear that. And we'll press play. So I'm going to fast forward this at 10x speed. It did take about 16 minutes to complete, so I've got a little under 2 minutes to give you a few words of encouragement. You can see on this board I'm cutting that this is my third attempt. Second successful, but if you look really close, you'll see that the run you're watching also took 2 tries. The router bit was jiggling loose on the first go round, so I had to start over. The Maslow took me probably 3 months between work and family obligations to get built, communicating, and calibrated. And a quick 15-minute video cuts out all the struggle and makes it look really straightforward. So if you're having a hard time, keep at it. I also realized that the best part of this is watching the design you made get built. But not everyone will have the time or money to buy their own CNC. I'd like to make mine available to you, so I've set up an online store. The link is in the video description. And if you'd like to test your 2D G-code to cut something out of wood, go visit my store and I'll help you get it done. I hope this was helpful.